Hello, everyone. My name is David Targett. I am one of the graduate assistants in the Office of Gift Planning this school year. And I have with us Dr. Carberry today. Thank you for being with us today.
I
So in typical faculty-focused fashion, I would like to ask Dr. Carberry a little bit about his history prior to becoming a teaching administrator at St. John's University.
I was an Army brat. I grew up on an Army base in Germany, went to high school, everything in Heidelberg. So I actually first got to the States when I went to college at Fordham, did my undergrad there, and then I went to grad school, got my Ph.D. at NYU.
Mhm.
And pretty well right after that, I came to St. John's. I'm currently teaching a bunch of the lab courses. I'm one of the lab supervisors. I'm the night guy because I'm a total night owl. But yeah, I teach the normal and honors organic chem labs.
Mhm.
And I also teach lectures for usually for the pharmacy, the general and organic chemistry 2 and 3 courses, which pretty well covers the entirety of organic chemistry. So that's really what I'm doing here.
Awesome. And what was your PhD in at NYU?
Organic chemistry. So
Organic.
I did my research in dendrimers, drug delivery vehicles. We ended up making a scaffold that we put a bunch of proteins on. It would allow it to insert into cells. We saw it had some antiviral capacity. It was able to deliver a payload into a cell. And then we just designed a bunch of scaffolds based on that they went further on in my group after I left.
Awesome. Sounds way over my head. Um, so obviously we've had coronavirus, it's affected everyone. Can you talk a little bit about how you've adapted to like this virtual learning environment and how you're still able to provide your students with like an A-class education?
We're trying.
Right.
Definitely, the labs are a lot harder than lecture courses. The lectures, I do favor those asynchronous. I've done some synchronous ones. And definitely the lack of being able to interact with the students is
Mm.
tough in the first place. Usually when I'm doing my lectures, I like people to stop me. I like people to ask questions
Right.
during the class because otherwise you don't really know what's going on. You're just
Mhm.
sitting there talking for a while. Whereas doing the lectures virtually, it's a lot harder to gauge everybody's reactions. You're not really seeing anybody's faces, anything like that. So definitely the whole idea is I like people to come to my office hours. I have discussion boards online.
Mhm.
I'd much rather to see, I know, especially in chemistry, if one person has a question, there's probably about 50 people who
Right.
have the same question. So it's one thing when somebody emails you a question and you email back versus if everybody can see that question, because then everybody's, maybe they didn't even know they had that question.
Right.
So it is good to use discussion boards and the lectures now that they're recorded, they can be, I do them asynchronously so they can be downloaded. Students can watch them on their
Mhm.
time, which I think is a lot easier because then you don't have to wake up at 9 o'clock in the
Right.
morning to get to a class. But I usually put my lectures up at least the evening before so the students can watch it on their time and then process it. And then they can come in the next day at the class time to office hours and ask questions based on the material.
Right.
So for the lab classes, of course, it's a little bit more difficult than that.
Mhm.
We don't want to lose the hands-on approach that you'd need in a chemistry lab,
Right.
especially for organic. There's a lot of techniques that you need to know. So we went to a hybrid version
Okay.
where we do switch on and off 1 week on, 1 week off. So we are still able to get some hands-on experience. Again, a lot of this is being put up on Blackboard and Canvas just
Mhm.
to make sure that we have effective pre-labs, because normally in a lab, we'd start out, everybody's read the lab procedure, but then we show a demonstration and how to build everything and theory behind it. Whereas now we don't really have that luxury to sit there and talk for 15, 20 minutes before class. We need to pretty well get started. Everybody's sitting here like this. So you can't really get too much information. So all of that is pre-recorded online. Students can watch beforehand. And that way we can get in the class. We can still go ahead and get the hands-on experience. A bunch of YouTube videos. We're just finding YouTube videos that you can set up for that. We're recording some of our own experiments as well. And then as the experiment's going, is pretty well just walking around, keeping the whole social
Right.
distancing, but still being able to say like, okay, this is minor change here, minor change here. So we're still getting that accomplished as well.
Right. So it sounds like it's all about just making yourself available to the students. Like this is the
We,
way to adapt to this
yeah,
environment. Just make
I
sure
mean,
you're
I always want to try to make myself as available as possible because definitely, you don't want to be one of those professors who teaches the class and is like, I'll see you never again. Like, you want to make sure that you're available and there to help with the students,
right.
especially organic chemistry. It's not easy. It's
No,
it's
it's not.
it's known as not an easy class, and it's mainly because everything is very, very different.
Mhm.
So I always want to make sure that there is availability there, that we're there to answer any questions as much as possible.
Right.
And during this time, it's even more important.
Exactly. So you said it. Organic chemistry in itself is very difficult. What is it about organic chemistry that made you fall in love with it?
That it is different, really. It's
Yeah.
it's so I wouldn't exactly say it's hard. It's just different is the biggest idea. Most people, you'd think of your liberal arts classes and your math, science, whatever. A lot of people see that switch, and then they like one or the other.
Mhm.
And organic chemistry is one of those things that kind of does some weird bridging thing. You go into a calc class or a gen chem, even physics, it's here's a bunch of formulas, memorize these formulas, put it in your calculator, do the calculations.
Right.
And organic chemistry really doesn't work like that. We don't really have that many formulas. We can say, here's a reaction. This is how you can do, an SN2 reaction, for example.
Mhm.
But then there's the whole idea of can you take that down, break it into some general form, and then reformat it into something that would solve a problem.
Okay.
So that's really what the issue is people are used to the idea of I need to memorize all of these formulas and go from there. And we always need to start an organic class by saying, do not memorize the textbook. You will run out of memory by chapter 5,
Right.
and that's where it goes wrong. And also, again, chapter 5, that's the stereochemistry chapter. So that's where we also say you need to pick up this molecule and rotate it around, and all of a sudden we're sitting in an art class there.
Right.
So the thing about organic chemistry is not that it's difficult, it's that it's just so different than anything people are used to.
Mhm.
So people who are very good at math and science and all that, then they get into an organic class and it's like, this doesn't follow the same formula I'm used to. So it is a little bit of getting used to it.
So it sounds like it's more intuition based almost.
I don't want to say it's
Like
intuition based. It's a lot more creativity based
creativity.
because you need to break things down into their base components and then start building off of that.
Right.
And once you realize, the Williamson ether synthesis looks like this basic reaction,
Mhm.
and then you can just substitute this group or that group or anything on there. It doesn't really affect the reaction. And suddenly you're able to say, here's some complicated thing you've never seen before, but each of the individual components of it. All you need to do is stitch together. So
Using
that's
that
the
creativity.
fun. It's the fun part about organic chemistry is now you're able to stitch all this together and really start to make these kind of creative leaps
Mhm.
that you don't really see when you're just doing plug in the formula. And then that's what I really like about how to do organic chemistry. And we always say, everybody's all, Orgo is going to stop me from getting
Right.
into med school because, and of course, if you go up to the doctor, they don't remember every single thing in organic. I know I'm also the kind of person, if I have to go to the doctor, I don't really offer what I'm doing because, you say you teach organic chemistry and the first thing they say is, oh, I hated organic. So it's one of those things. But what it does is it really helps you learn how to think.
Right.
So it's not necessarily the material that is going to be useful for doctors and anybody like that, but it is the method of thinking, the way to say, here's a bunch of facts I have, here's how I can break it down and start to solve problems with these individual components and stitch together into something. That's the whole method of thinking, and that's what organic chemistry is really about.
And that's what it sounds like the most important thing. It allows you to then go into different disciplines that
Mhm.
require like a specific way of, not a specific way of thinking, but a creative way of thinking.
Yeah. So then this is the great thing about organic chemistry, is because this is the big class where you start to say, I'm not just plugging and chugging anymore. I'm making answers.
Right. Well, this was great. I know our alumni are going to enjoy this conversation. I just wanted to thank Dr. Carberry again for taking the time to be our faculty focus of the week.
Yep, no problem. Thank you so much.